problem on the left reads, a farmer has 91 acres on which to plant oats or corn. So I'm letting x equal acres of oats and y equal acres of corn. And the first inequality I have is x plus y is less than or equal to 91 because the acres of oats and corn together cannot exceed 91 acres. Then each acre of oats requires $18 capital and 2 hours of labor. Each acre of corn requires $36 capital and 6 hours of labor. But we have to remember the labor costs are going to be $8 an hour. The farmer has $2,100 available for capital. So my first inequality with that is $18 is required for each acre of oats, and then corn requires $36 of capital for each acre of corn, and that total needs to be less than or equal to $2,100. Now when it comes to the hours of labor, even though it's only 2 hours for oats, we have to multiply that 2 by the cost per hour, which is 8. So 2 times 8 is $16 for every hour of oats. And for corn, it's going to be $48 because it is $8 per hour and there's 6 hours. And that needs to be less than or equal to $2,400. The revenue is $50 for every acre of oats and $113 for every acre of corn. So those are my inequalities. Now the most challenging part of this is that it actually asks what's the maximum profit. Usually it's the maximum revenue. So I do need to think about profit as revenue minus cost. First of all, the revenue is going to be $50 for every acre of oat and $113 for every acre of corn. So that'll be their revenue. And then in this next bracket, I have 2,100 minus 18x minus 36y. And that comes from the capital because there's $2,100 of capital and it's 18 times the number of acres of oats and 36 times the number of acres of corn. But we may not use all of the capital, so there'll be some money left over, possibly. So 2,100 minus the 18x and the 36y will be the remaining capital that's left over. Then the remaining money for labor is 2,400 minus 16x minus 48y. And if we use our algebra skills and simplify this, I add the 2,100 and 2,400, which is 4,500. And then I add all my x's together, 50x minus 18x minus 16x to get 16x. Then 113y minus 36y minus 48y gave me 29y. This is my profit equation that I want to maximize. Next, I type all my inequalities into a graphing calculator of some sort, and I use Desmos. Like most graphing calculators, I like to use the reverse inequalities and also the restriction that x must be a positive value and y must be a positive value. So we can see the feasible region is this white section. And all of the critical values of that feasible region are the ordered pair 0, 0, 0, 50, 50, 33.333. Now, it's very important in this problem to actually use the fraction equivalent of this, or else your answers are not exact. So I use the ordered pair 50, and then 33 1/3, because 0.3 repeating is 1/3. I also have the ordered pair 91, 0, and I need to turn off this label so I can get to the other one. The other one is 65 1/3 and 25 2/3. So here are all my critical points, maybe not in the best order, but they're all there. When I put those critical points through the profit equation that I'm trying to maximize, I put the x values in for x, of course, and the y values in for y. Important piece is the fractions. If you have a difficult time entering 33 1/3 in your calculator, you can always change that to the improper fraction, and the improper fraction there would be 100/3. So you could use that instead, or you could use 33.33333 and just put a lot of decimal places in. I did that for all the following critical values and came up with a maximum profit that is occurring here in the second row of 6,289.67. And so that ordered pair is 65 1/3, and then 25 2/3. When you type the answer of 65 1/3 into MathExcel, it'll want it as an improper fraction. So as a reminder for typing that as an improper fraction, you would take the 65, the whole number, multiply it by the denominator of 3, and add the numerator of 1. So I would type that in as 196 over 3.